Alright, today is kind of like yesterday, but we have variables. And actually, people find that the variable part is easier because all you have to worry about is how many of them can I take out from under the root. So let's look at number 1, a to the 13th. Well, there are 13 a's under this fifth root. I need a grouping of 5 to pull 1 out. Well, I can get 2 groupings of 5. So if I wrote that out, which I'm not going to, but well, yeah, if I had 13 eighths, I can pull out 2 of them. And to pull 2 out, I use 10 of them. Hopefully you guys see that. I use 5 to pull 1 out, 5 to pull 1 out, so I've used 10. And that means that there are 3 left over. And that's all you got to do. A squared, fifth root of a cubed. Can't pull those 3 out because you need 5 to pull them out. Now, 2 is a combination of numbers and letters. Okay. First off, notice how it's a fifth root and there's a negative. Always pull the negative out of a fifth root if you can. So my answer is going to have a negative. So my negative's out already because the fifth root of -1 is still -1. And then I have the fifth root of 64 is 2 to the 6th, so break it down, a to the 7th. Well, I have 6 2's under here. I need 5 of them to pull 1 out. So I'm going to pull 1 out, and I'm going to pull 1a out. And I'm left with a fifth root of, there's 1 2 left in there because I've used 5 of them, and there's 2 a's left in there. And that's my final answer. That's it. Alright, 3. Well, again, this one you can just kind of look at. This is the same thing as saying the fourth root of x to the 4th on top over the fourth root of y to the 8th. Well, I need 4 to pull 1 out. Well, I have 4, so I could pull an x out. On the bottom, I need 4 to pull a y out. I can do that twice. So I can pull a y squared out, and there is no remainder, so there's nothing I need to do after that. That's my final answer. Alright, for this one, this is kind of like before. We have to move things around. 18 divided by 6, there'll be a 3 on top. I'm going to just kind of fix this here. We have an r to the 4/4. The reason why I did that is there's an r to the 1/4 on the bottom. I'm going to rewrite that down here. There's an s to the 2/3, and there's a t cubed. Now the t cubed comes up because that's a negative cube, so t cubed. Alright, so the next thing I want to do is simplify these. And actually I'm going to just do that right now. 4/4 minus 1/4 is r to the 3/4 on top. And we're almost done. Now some of you guys might go, okay, yeah, that's pretty simplified. However, when you have anything with fractions, you need to get a common denominator so you can put them under the same radical symbol. So down here I have 3. I'm going to make these, what, 12ths? So 3/4 is the same thing as r to the 9/12, and s, my s's are not that great, sorry about that, s to the, I need to multiply by 4, 8/12. And then t cubed. You don't have to do it with the t because those will just come right back out anyway. They're already out there. So I can finally write my answer as 3t cubed, the 12th root of r to the 9th and s to the 8th. Now some of you guys might be like, well, but you can simplify 8 over 12. And we were doing that in 9 over 12. You can, but when you're dealing with more than one base, like r and s, you want a common denominator. So you do not want to simplify it there. You only simplify if it's like one thing. Alright, number 5. We got a 4th root of 12. If I break that down, I get 4 times 3, or 2 times 2 times 3. Nothing can come out of there. So I'm not even going to worry about the 12. It's stuck in there. Alright? So this is where you kind of divide everything by the index. Or think about it. I have 4 d's. I need 4. So I could pull a d out. E to the 9th. I can use 8 of them to pull 2 e's out. F to the 14th. Well, 4, 8, 12. I can use 12 of them to pull 3 out. Now you have to remember what you pulled out. Now I have left the 4th root of 12. D to the 4th is gone. E to the 9th, we used 8 of them, so I have an e and f squared. And that's my final answer. That's all you have to do, is figure that out. Now 6 is a little more challenging just because there's 2 of them. They're both fifth roots, so we can multiply everything in. We can multiply this all across. So let's do that first. I get the fifth root on top of 2 to the 4th g squared k cubed over the 5th root of 2 to the 5th h to the 10th. Now before you start rationalizing the denominator, take a look at the bottom and see what you have. Notice that you have 5 2's, so you can pull one out. So I'm going to do that right now. I have a 5th root of 2 to the 4th g squared k cubed, and then the bottom becomes 2, I pulled one out, and h squared. And guess what? That's almost all you can do. Again, with numbers, I'd like you to multiply them out if they're smaller. So my final answer would be 5th root of 16 g squared k cubed over 2h. And that's it. 2h squared. Forgot my squared there. Alright, so that is the final answer. Don't have to rationalize because it was already done for us. Now, 8 we can't do anything with because these are not the same bases yet. It's not the 4th root of 6x. It's the 4th root of 6x to the 5th here. But we can pull one of the x's out. See how there's 5 of them in here? So I'm going to take 4 of them and make it 6x, and then the 4th root of 6x, because there was 1x left over, plus x, the 4th root of 6x. Now these match. These are the same kind of base. So when you have the same base, you can add coefficients. I have 6x and 1x, so 7x, 4th root of 6x. And that's my final answer. But again, first thing we did was pull that out. Now this one, I was just showing that you can simplify by using more exponent properties. We have x to the root 6 times root 3. So we have x to the root 18, and just simplify root 18. Square root of 18 is 3 root 2. So x to the 3 root 2. That's all you can do. You don't rationalize anything when it's a power, just leave it as is. Okay, so that was playing around with exponents, rational exponents with variables. Again, same thing. If you need a certain amount to pull it out of the radical symbol, depending on what the index number is.